Let's assume you start with a simple test. You just want to drive along a lane and you want to make sure that you're not leaving this lane. So maybe you just want to check that lane markings are correctly tracked and that the controller of the vehicle is working well. And then you could test this for 3 different parameters, like different lane widths, different lane curvature, and maybe also the change of curvature over the length of the lane might change. And then you have some vehicle parameters like the velocity, position in X and Y direction, heading, yaw rate, and so on. And even if for each parameter you use 20 test values, then you have already 20 to the power of 3 cases for the lane parameters, and then 20 to the power of 8 cases for the ego vehicle parameters. And then, of course, there's more than one lane typically. So if you have several lanes, then you have to take the power of the power. So you have 20 to the power of 3 to the power of 5 just for static scenes. And then you have all the dynamics, like the other obstacles in the environment, which also have different position, velocity, orientation, and so on. And then you have more than one vehicle. So here we assume a maximum of 10 vehicles. Of course, it could even be higher. But if you multiply all these numbers, then of course, as always, when you do a full factorial test generation, you have a high number of scenarios. In this case, it's more than 10 to the power of 80, which is of course infeasible. So you cannot really test the system before it's deployed. And most of these scenarios will never be encountered by the vehicle. The idea now is that we do everything online. There will always be some offline testing, but most of the verification should be transferred online, where each situation as it is will be considered. We will formally verify the actions that are planned in this current situation. And of course, this has to be done in a just-in-time manner.